Okay, so today we're going to be starting chapter 5, which is all on solving systems. Okay, we're going to spend probably either 2 or 3 weeks, okay, on this chapter. Okay, it'll be pretty much the rest of term 3. So first, I'm going to talk to you guys just what a system is, and we're going to look at 3 different ways to solve it. Okay, the first way is graphing. Okay, so for graphing, we're not going to do a lot with it. Okay, we're going to see why graphing isn't always the best way to do this, right? For some problems, it's okay, but for a lot of problems, graphing is not the best way to do it. So I'm not going to focus a lot on this method. The 2 methods we're going to focus on a lot are called substitution, which is going to be all this week after today, and then elimination. You don't have to worry about elimination until next academic week, all right? So that's basically what I just said to you. So for the rest of the term, we are solving systems, and I'm going to show you 3 different ways to do it. We're going to look at 2 out of the 3 ways this week. Okay? One way we're going to look at is way more important than the other. This is not the important one. Still going to give you a question or 2 on the test with it, but this is not the one we're going to focus on for the rest of the week. Okay? We're going to look at a different one tomorrow. All right, so on your first bullet on your guided notes, it says a blank is a set of, and then it says 2 or more equations using the same variables. You want to fill in system of linear equations. Okay, there's another blank in the sentence. We'll fill that in a second. Okay, so a system of linear equations. And we're going to make one up in a second so you guys can see exactly what it looks like. It's important that when you're solving a system, it has 2 equations. It has to have 2. You can do more than 2. You'll do more than 2 when you take Algebra 2. Okay? But we're just going to do 2 equations. And each of the equations has the same letters in it. So if there's an x and a y in the first equation, then there's going to be an x and a y in the second equation. So each equation uses the same letters. Now, it's usually x and y, but if it was a word problem about, like, let's say I was selling adult tickets and children tickets, I may use A for adult and C for child. I could still use x and y, but a lot of times in a word problem, I try to use a letter that makes sense. And the last blank you have to fill in says usually we have to solve for 2 variables. Okay, 2. In fact, I think pretty much every problem we do in here, you're going to be solving for 2 variables. But when you get to Algebra 2, you might solve for 3 variables, or 4, or more. Right? It starts to take, when you get above 2, it starts to take significantly longer. All right, very long. Depends how many variables you're going to solve for. Most people, once you get above 4, you're not doing it by hand anymore. You're usually using like a little graphing calculator to help you, or a computer, or something like that. But 2 is pretty doable. 3 is pretty doable by hand, even 4. But when you start to get above that, it gets kind of hard. So let's come up with an example of a system of linear equations. If you want to write this off to the side, you can, but it's not going to be something that we solve. Okay? All right, so let me write down one equation and see if you guys can give me a second one. So it says 2 or more linear equations. Okay, so remember when we talked about linear, I used the term like funky stuff, no funky stuff, right? You can't have exponents like that. You can't have letters in the bottom, okay, things like that. You basically want things that look like y equals mx plus b. That's what you want. Or it could be rearranged so it looks like y equals mx plus b. Right? So let's write this one down. 2x plus y equals 4. Is it possible to take that equation that I just wrote and make it look like y equals mx plus b? Yeah, what would you have to do?
Yeah.
Exactly. I'm not going to do it. It's not asking me to do that. But that is an equation. If I minus 2x from each side, it would say y equals negative 2x plus 4. So I could rearrange that in y equals mx plus b, which means it is linear. Okay, if you can write it in like that. Now, can somebody else give me another equation that looks kind of like this, but not the same numbers? Okay, and you can use subtraction if you don't want to use addition. That's fine too. Can somebody give me one more equation that looks kind of like that? Yeah.
No, I have a question. Does like the number have to be with the x or
No.
with the y?
No, you can put a number with either the x or the y. Because remember, technically there is a number there. It's just a 1.
Yeah, that's
Yep, so you can put any number with the x, any number with the y. You can put add or subtract, and you can put any number you want on the other side. We're just making one up. Kelsey?
X plus 4y equals. Does it have to like equal? Can it like equal anything?
Any number, yep. Could be a fraction.
12.
12. There you go. That's a system of equations. And the goal now, which we're not going to do because since we just made this up, it's probably not going to come out to a nice answer. But the goal would be to solve for x and y. So when you're done, you'd have something like this. Now, the tricky part is you have two equations. Just look at the bottom one for a second. 4 times what gives you 12?
3.
3. So if I let x be 0 and let y be 3, and I said to you what you guys did in the warm-up, check that answer, it would work. Plug in 0 for x, you get 0. Plus, if you plug in 3 for y, what's 4 times 3? 12. And what's 0 plus 12? 12. So plugging in 0 for x and plugging in 3 for y works. I'm not saying it's the only one, but it does work. Now, the problem is you have to be able to plug those same two numbers in up here, and it also has to work. So once you find an answer that works, it can't just work in the bottom equation, it has to work in the top one. Let's check it. If you plug in 0 for x, what's 2 times 0? 0. And if you plug in 3 for y, what's 1 times 3? 3. And that plus that is supposed to equal 4. Did it work? No. So the problem is you did find an answer that worked in the bottom equation when you plug in a 0 and a 3, but plugging in a 0 and a 3 didn't work at the top. So you've got to find one that works in both. Now, just trying to guess different answers, you're going to be here all day trying to figure it out. So I'm going to show you guys how we can find the exact answer without trying to guess. And there usually is only one answer that would work in both. Only one. One value for x, one value for y. Yeah.
Why can't you put, instead of plugging in 0 for x, oh, never mind, that wouldn't work at all.
Right. So you might say, well, what if I put in 0 here and I put in 4 here? Okay, well now that works in the top because 2 times 0 is 0. 1 times 4 is 4. 0 plus 4 is 4. But if you plug in a 0 and a 4 in the bottom, now that doesn't work. So we got to find one that works in both. That's the whole thing that we're pretty much going to be doing for this week. Trying to find one that works in both. Okay. And again, I'm not going to solve that one with you guys right now because it's probably a pretty bad answer with decimals. Okay, so the second bullet. It says a solution, which I actually basically put a box like that to show you guys. A solution of a system of linear equations. That's what you want to fill in on that line. A solution of a system of linear equations with two variables. It's basically a coordinate, which, I mean, you can write it like that, like I did in this box. Tell me x, tell me y. Or you could write it like this. Tell me x, tell me y. It's the same thing. Whether you write what's in box, call that one box 1, or box 2. Every problem we do this week, you can either write your answer like I did in box 1, x equals y equals. Or write your answer like I did in box 2. X comma y, the coordinate. It means the same thing. So the key is, it's an x and a y value that when you plug them in, works in each equation. Not just the bottom one, not just the top one. You have to find numbers that work in each. That's why when you get to like 3 equations and 3 variables, it's even harder. Because now you've got to find 3 letters that work in every equation. Okay? We're going to stick with 2. All right. And the last thing before we look at an example is this tells you how to check an answer. Like if you think you got the answer right, this tells you how to check it. And checking it is what you guys did in the warm-up. What did we have to do with the numbers they gave us in the warm-up? The very first thing, we have to take the number and do what with it?
Identify.
Okay, so we identify like, x equals 4, and then we took the 4 and did what?
Plug it in.
Plug it in, exactly, perfect. So on the last line, the bullet says to determine if a coordinate, or ordered pair, same words, is a solution. You plug it in and see if you get a true statement. Okay, I gave you guys an example of one up here that was false. When you plug in a 0 and a 3, we got 3 equals 4. No, that means it didn't work. Right? So you plug in the coordinate that you have and see if you get a true statement. So for the first few problems, I'm not even going to have you guys solve anything. I'm basically going to say, here's a problem. Here's the answer somebody got to it. Check their answer. Did they do it right? That's all. Okay. Does everybody have what's in bold there? So plug in the coordinate, or in other words, plug in the x and the y value that they give you into the equation that they give you and see if it works. All right, so let's look at an example. So, in example A, there's the answer to the problem. Maybe. It's kind of like you're checking somebody's work. They got the answer 2, 5. That's the problem that they solved. Does everybody have what's on the left so I can make on the right a little bit bigger? Now, they didn't specifically say it, but you should kind of know by looking at the coordinate. What did this person get for the x value?
2.
They got 2. What did they get for the y value?
5.
5. If they wanted, they could have written the answer like this. You guys can do this on the test. X is 2, y is 5. You don't have to do both. Okay, it's the same thing. Okay, just do one or the other. All right. So, what do I have to do with the 2 and the 5 to see if they got the right answer?
Plug it in.
Plug it in. To which equation?
Both.
Both, exactly. We're going to do one at a time. Let's start with the first one. X plus y equals 7. Okay, so we're going to check and see if they got it right. Julia, what am I plugging in for x? 2. So let's plug in a 2. Elizabeth, what am I plugging in for y? 5. I'm just going to put a question mark there because I don't know if it equals 7. That's what I'm checking. If it does, that's good. 2 plus 5 gives me how much? 7. Does that equal 7? Does 7 equal 7?
Yes.
Yeah. We got the same thing on each side. So what that means is that answer worked in the top one. We're not done. It doesn't mean it works in the bottom one. We have to check that one too. right? But we did find one that works in the top. Another one that would work in the top would be 1 and 6.
Why did you put a question mark there?
Because before we finished it, we didn't know if it worked or not.
Oh.
Now we do. Okay. Let's do the next one. 2x minus 3y equals negative 11. Right. So we're going to fill in something for x. We're going to fill in something for y. And remember in the warm-up, we always put parentheses when it's multiplication around what we filled in. Because if you don't, and you just put a 2 right there, it's going to look like the number 22. You don't want it to look like 22. You want it to look like 2 times 2. All right, and I mean, you can put an equal sign here, but I'm just going to put the question mark because I don't know yet if what's on the left is going to equal negative 11. I hope so, but we'll see. So Tristan, what am I filling in for x?
2.
2? And Joe, how about for y? 5? And now we'll do it out. Gianna, what's 2 times 2?
1.
And 3 times 5 gives me 15. What's 4 take away 15?
Negative 11.
Yep. So, did that one work?
Yeah.
Yes. So now we can answer the question. Is that ordered pair a solution?
Yeah.
Yeah.
So the answer here is yes. Now, you could try to find another one, but you won't. The only numbers that would work in both is if you put a 2 in for x and you put a 5 in for y. You might say, well, could I put a 1 in for x and a 6 for y? Yeah, on the top one. 1 plus 6 would give you 7. But I guarantee if you put a 1 and a 6 in the bottom, it wouldn't work. Okay? There's usually only one answer that works in both. So for you guys, where this would come up is like the last step in the problem. Once you do it, you're going to figure out this coordinate yourself. Then you check your answer to make sure that you found the right one. Right, so this would be like the last step in the problem. Okay, let's try this one. They have negative 2 and 0 as the coordinate. So Princess, what did they get? What did this person get for x when they did all this work? They got negative 2. And what did they get for y? 0. So the first number in the coordinate is your x, and the second number is your y. Okay. So Mackenzie, how do we check if that answer is right? Plug it in. Which equation? Both. Okay, one at a time. So let's start with this one. I'm going to put a question mark there because that's what we're trying to figure out. Aileen, what am I plugging in for y?
0.
0. Negative 2. Just leave some space. We just copy down everything except what we have to fill in for. Olivia, what am I filling in for x?
Negative 2, yeah.
Yeah. And now we'll do it out and see what we get. Well, nothing to do on the left. That's done. Maya, what's negative 2 times negative 2?
Negative 1.
Careful. Negative times a negative?
Oh, sorry, positive.
Positive. And that minus 4 just stays right there. So negative 2 times negative 2 is 4. What's 4 take away 4? 0. Did the answer work?
Yeah.
Yes, it did. So can we just say, yes, it works, we're done? No, it worked in the first one. You got to check that it works in the second one. And watch what's going to happen this time. Y equals negative x plus 4. Okay. Kelsey, what am I plugging in for y?
0.
0. Now, be careful when you plug in for x. What's in front of x in the second equation right now?
Negative.
That negative sign. That's going to stay right there. Now, inside the parentheses, fill in for x. What number am I filling in for x?
Negative.
-2. Sometimes people mess that up. There's already a negative out in front of the x. That's that right there. Then there's another negative in front of the number 2.
What if that just changed to 2?
So that's just going to change to 2. So 2 plus 4. What's 2 plus 4? 6. Did that coordinate work in the bottom equation?
No.
No. That is not true. 0 does not equal 6. You have to get the same number.
Oh my god.
Okay? So what that means is whoever solved this, they found a coordinate that worked in the first one, but not the second. So the answer here is no. That is not the right answer to the problem.
Why'd you put the x next to 0?
I just put an X meaning like this one was right, this one is wrong. It didn't work. So if that happened to you, what you'd have to do now is go back and do this all over again. Okay? And that's what I'm going to teach you. How do you get this coordinate yourself? Okay? And there's 3 different ways to do it. I'm going to show you one today.
Are we gonna learn all 3?
We're going to learn one today, and then we're going to spend the rest of the week on the next one, and then we'll spend another week on the one after that. So we're not going to do all 3 in this week. No, only 2. And there's even a 4th way to do it if you use the fancy calculators that you guys used last week. But we don't use those for this. All right. So take a second and try that one on your own. Check if the coordinate that this person found works in the top, and see if it works in the bottom. Okay? And the 3 things that could happen is it works in both, works in one, or it works in none of them. Now, we haven't had this happen yet, but if you check it and it doesn't work in the first one, do you even need to check the second one?
No.
No. Because if it doesn't work in the first one, you're done. You already know it's not a solution. I don't care if it works in the second one, it didn't work in the first one. So, if you check one right away and you see it doesn't work, you can stop. Okay, so I'll give you guys about 60 seconds or so to give that a shot.
Oh.
All right, guys, let's take a look. What do they want me to plug in for X this time? John? 1. And Stephen, what do they want me to plug in for Y?
4.
4. Okay, let's check the top one. So we're going to plug in 4 for Y, and the question is, does that equal 3 times, what did I fill in for X? 1. So what's 3 times 1? 3 plus 1 more. 4. Okay. So did it work?
Yeah.
Yeah. So does that mean we can write down, yes, it works?
Yes.
Yep. Yep. Just sign out.
I don't know.
So does that point work?
Yeah.
Yes.
It works in the first one, but what do we have to check?
The second one.
Check the second one. Y equals -1 plus 5. How about, Tristan, what's -1 plus 5?
That would be 4.
Yep. Did it work?
Yes.
Worked? Worked? Perfect. So we can say that that yes, it is the solution. So yes. Now, I want to show you guys something about this problem real quick on this calculator. You don't have this calculator, so just watch. Watch. I'm going to type in each one of those equations and make a picture. Like 3 is the slope, 1 is the y-intercept. I'm going to type them each in. So y equals 3x plus 1. Can somebody tell me what the other one was? Because it's underneath my calculator.
Y equals negative x plus 5.
Negative x plus 5. Now, I'm going to hit graph. Watch what happens. The first line is going to be in blue. The second line is going to be in red. Now, I want to take that and make it a little larger so you can kind of see it. Those two lines cross right there. What would you say the coordinate is for where they cross? Yeah. 1, 2, 3, 4. Where they cross looks like the coordinate 1, 4. Everyone agree?
Mm-hmm.
Look at the point they told you to check. 1, 4. So, does that give you a hint at how you can figure out that coordinate yourself?
Yes.
What do you have to do?
You have to look at where the lines cross.
Exactly. That is one of 3 ways to figure out the answer to this problem. Look at where the lines cross. Right? And that's the way we're going to look at today. So basically all it's going to mean is drawing each line, telling me where they cross, and there's the answer to the problem. Now, where graphing can get kind of lousy is if they cross at a decimal. You're not going to be able to tell, even if you use graph paper. Like, how could you tell if they cross at like 3.7? You can't, right? This calculator can do it. On this calculator, it has a feature. I can go second, calculate, and the 5th one, I don't know if you guys can read it, it says intersect. And the calculator can automatically tell me where they cross. I'll put that here so you can see it. It tells me that they cross at 1, 4. X equals 1, y equals 4. So even if this was messy answers like decimals, the calculator could still do it. But we're not using those, we're just going to use graph paper. So I'm going to try to make the answers as nice as possible. Okay, nice numbers. All right. So in the first example we did and the third example, the coordinate worked. Okay? We wrote yes and we wrote yes. The second one we did was a no. Didn't work. Now, we already answered this question, but now you guys can, is there a spot? No, you don't have to write that part down because I just showed it to you. Right? The question is, how can a coordinate be on 2 different lines at the same time? Well, it can be on 2 lines if it's where they cross. Okay? So the coordinate 1, 4 is on the blue line in this picture, and 1, 4 is on the red line. Okay? It's on both because it's where they cross. All right, so last thing for notes, and then we just finish up with a few examples, is how to solve a system by graphing. Okay. So step 1. So on your first line, you want to write, graph the equation in y equals mx plus b. That's called slope-intercept. Okay, so remember, B is your y-intercept. That's where you cross the y-axis. You put that first. What does m stand for in y equals mx plus b? Yeah. The what? The slope. Yeah. And does anybody remember there's 2 words that begin with R? Slope is, yep, rise over run. Very good. So from here, this should be reviewed, as long as you remember how to graph a line. Okay? Put a dot where your y-intercept is, and then use your slope to get another point. And that will make a line. Okay? And you're going to make 2 of them. One for the first equation, one for the second. Step 2. Estimate where you think they cross. Like I said, 90% of the time, I'm going to try to have it cross at a nice number, not a decimal. Because if you're graphing using graph paper by hand, it's very hard to tell if they cross at a decimal. Okay, so we're going to try to make the answers come out nice. Then, once you estimate where they cross, step 3 is what you guys just did in examples 1A, 1B, and 1C. Step 3 is to check your answer and make sure it works. Okay, so the extra step for you guys now is you have to find the coordinate where they cross yourself and then check it. I'm not going to give you where they cross anymore. I will on some. Like in the homework, I'll give you some where you just have to check it. And then I'll give you some where you have to graph it and check it. But if it's a graph problem, I'm going to give you graph paper on the homework. Right? Same thing on the test. If it's a graph problem, you'll have a graph right on the test. Yep. Yeah. Bless you. Okay, where I wrote slope equals rise over run, you don't have to write that down. If you don't remember it, you might want to off to the side.
Are we on a reference sheet for this test?
Yep, we're going to have a reference sheet, and we're also going to have extra credit on Thursday when we do the review.
How high do you think 55 can get by the end of the week?
I don't know, we can look at it though, I have to do it out. Just see me after if you want to know. So yeah, we'll have extra credit, probably the kind of thing like every problem you get right in the review, you get an extra point on the test, right? But we got to do the MCAS. We got to do the MCAS thing first. Okay. Does everybody have the 3 steps? All right. So here's a system of equations. And when I'm done, I want to have something like this. And I want to know each of the numbers that should go there. That's the x, that's the y. Okay. Are these equations in y equals mx plus b? What do you think? Blake, are those both in y equals mx plus b?
Yeah.
Yeah, so they're good to go. Okay, example 2b, if I just click to that, I'm going to come right back to this one. Might be down here. Actually, that one's good to go too. So you don't have to fix anything. It's already ready to go for you. Okay. Let's call this one equation 1, which I'm going to do in black. Equation 2, I'll do that one in red. Okay. Who can tell me for equation 1, what's the first thing that I do to make my graph?
Plug in. Oh, no.
No, we don't have anything to plug in.
Oh, you
I have to plot my
line
y-intercept. What's my y-intercept in equation 1?
1.
1. So that's a 1 on the y-axis. Now, the next thing I need to use is my slope. Slope is rise over what?
Run.
Run. Now I can see in the red one, number 2, my slope is 3. But there's no number in front of x. So what can I put in front of x if I want? I can put a 1 there. So my slope is 1. How do you make 1 a fraction? You can make any number a fraction by putting it over what? 1 over 1. So from my y-intercept, can anybody tell me which way I go and how much to get another point? Yeah? Up 1 and to the right, yes. Up 1, right 1. Okay, so I'm just going to do that. You don't have to do it that many times. It's just the more times you do it, it does kind of have to be accurate, because if you're not going to be able to estimate where they cross. So I'm also going to go like this. I'm going to go back the other way. That's just to help me draw a really, really good line. If I do that many dots, I don't even really need a ruler. I can just kind of go like that. That looks pretty good. Okay, but again, where you graph, it's very, very, very important you graph it accurately. It can't be kind of a good graph. It has to be like perfect graph. That's why solving a system by graphing isn't always the best way to do it. Because you have to draw a really good graph. All right. Now let's do number 2. What's my y-intercept on number 2? -5. So we're going to put a -5 right there. That's my y-intercept. Now, Kayla, what's my slope? Anybody help her out? What's my slope in number 2?
3.
3? And how would you make it a fraction? 3/1. So, from the y-intercept, can somebody tell me which way I move and how much to get another point? Up 3 and then, well, it's this number. Remember, if it's positive, you go up. If it's negative, you go down. This number, we always go right, unless you're at the edge of your paper and you want to go back the other way. Okay, so up 3, right 1. 1, 2, 3, right 1. My hope is that I get a red dot right on that black line in a second. Let's see. Up 3, 1, 2, 3, right 1. Up 3, 1, 2, 3, right 1. Look what happened. I already have the answer to the problem. I don't even really need to do any more. Okay. I'm going to finish it though. I'm going to go up 3, right 1, and I'm going to draw my red line. Like that. So remember, the answer is where the lines what? Where they intersect. My graph's not perfect, but it's pretty close. Jaden, where does it look like those intersect?
4y x.
X is 3.
Let's see.
3 comma what? 4. Yeah. So if you go right 3 and up 4, it looks like that's the answer. And now you guys are at the step that you did the first example at. Check 3 comma 4 and see if it works. Okay. So how about Lucas? How do I check if that point works?
Which one?
The point that we think is the answer.
Could you do it in the first examples?
Yeah, do what we did in the first example. So take those 2 numbers and do what?
Plug them in.
Plug them in. So y equals x plus 1. Let's check that one. What did we get for y? About mine? What did we get for y?
For number 2?
For the one we just did.
Like, I'm
So we got an answer on the problem we just did. What did we get for the y value of the answer?
like when they intersect. 3 and 4.
So what's the y value? So we wrote down earlier right here.
Oh,
The y value was 4. So we're going to fill in 4. Blake, what did we get for the x value? 3.
3.
We already wrote that right there. So x is 3. Does 3 plus 1 give you 4?
Yes.
So what does that mean?
It's correct.
Correct in which one? The first one. Yep, it worked. Now check the second one. Y equals 3x minus 5. Okay, what do we get for y again?
4.
4. What do we get for x? 3. What's 3 times 3? 9 minus 5 is 4. What does that mean? 4 equals 4, which means it's right. It worked in the first one, it worked in the second one, so we got the answer right. So that's why it's important that you're pretty accurate with your graph. Okay, we're gonna do the last two together because I just want to make. I mean, we still got about 20 minutes. I just want to make sure we get through them. So we'll do one more of this type, and then the last one will be a word problem. I think with the word problem, I'm not gonna have you guys graph it because it's a graphing one. All I want to do is be able to set it up. Okay. But this one I want you guys to try and graph. Okay. Are my equations both in y equals mx plus b? Yes. So Julia, we'll call this one again equation 1. Call this one 2. What's the first thing I would do to graph equation 1? What's the first thing we did in each equation last time? Do we use the slope first or the y-intercept? No, the slope is the second. So the first thing we use is the y-intercept. Can somebody tell me what I do with the y-intercept? Yeah, I graph it. So what's the y-intercept in equation 1? 4. How do I graph that? That's it. Just go up 4 and put it down. So that tells you that's where it crosses. Now the second thing we use is the slope. What's my slope? Princess, what's my slope in equation 1? Yes, -1. Now, I need it as a fraction though. I need rise over run. So what number could I always put in the bottom? If there isn't one there. A 1. Now, from the y-intercept, this is telling me to go which way and how much, and then which way and how much. Yeah. Perfect. Down 1, right 1. So I'm going to do that a bunch of times. Again, that's way more than you need to. I'm also going to go the other way, just so I do my whole graph, and I won't even need a ruler if I do it that way. All right. And then just try to stay right on the dots. That's pretty good. Okay, now the second one. Okay. What's the first thing I have to do to graph the second one? Graph the y-intercept, which is where this time? Negative how much? Yep. So there's your y-intercept at -8. And who can tell me what my slope is in the second one as a fraction? Joe? 2 over 1, which tells me to go which way, how much, which way, and how much?
Up to 1.
Up to the right. So up to right 1, and my hope is I hit that red line. Let's see what happens. Up to right 1, up to right 1, up to, done. Technically, we already have the answer to this problem. I'm just going to finish it off. Draw my line. Might be a little off at the end, but that's okay because I already have the answer. And where does it look like those lines cross? 4, 0. No. I'm not going to check that one. You could check it just like we did. And if you plug it in, I'll just do it in my head real quick. It works in the first one. It works in the second one. I just checked it in my head quickly. So that is the correct answer. Yeah.
Do we have to check all our answers?
I'm probably going to have you just check like 1 or 2. That's why we checked the first one, but I didn't do the second one. Okay. Any question on that? So hopefully you can see why graphing may not always be the best. First of all, if you have big numbers, your graph could go off the page. So then what happens? If your piece of graph paper is not big enough, then you've got to start over and get a bigger sheet of graph paper or number your maybe go by 2s or something, right? So graphing works okay as long as the answer is nice. If your 2 lines look like this, how are you going to tell where the green and the blue one cross now? I mean, what's that, like negative? You can't really tell. It's like 1, 2, 3, 4, 5, negative 6.2. I can't really tell. So graphing is not always the best when you get decimals, right? But if I give you a graphing one, which I will, it's not going to be a decimal, okay? All right. So last problem. Notice there's no grid here. So all you have to do is set up the system. Okay? So this is like one more step, but I'm taking away a step. You have to come up with these equations now. Okay? I'm not telling you what the equations are. So you have to figure out the equations, but then you don't have to solve it. Okay? You just have to set it up. We'll practice solving the ones that you set up more tomorrow. Another reason I don't want to solve it is because the number is going to be kind of big. So that means I need a really big piece of graph paper. And we're not going to go that big when we graph stuff. We're going to keep the numbers small. All right. So every problem that we've done has involved how many letters in each equation? How many? 2. So when you set up a system of equations, you're going to have 2 equations. Each equation is going to have 2 letters in it. An x and a y, and an x and a y. So let's just read it and then see if we can figure out what x and y are. You're selling 2 types of candles. Small candles are $4. Large candles are $6. At the end of the day, you made $144. So you sold some amount of large, some amount of small candles. It says that you sell 4 more large candles than small candles. So when you add up how many you sold, you sold 4 more large than small at the end of the day. How many of each type of candle did you, that should say, sell? You're not buying them, you're selling them to other people. So let's look at, like, what could x be here? X could represent what? Like, what's one thing you don't know that they want you to find?
How many small candles?
Sure. I'm going to write that off to the side. X is, we'll say, number of small candles sold. So that's what X is going to be. What about Y? What's something else we don't know that they're asking us to find? Yep. So Y is number of large candles sold. Now, we have to set up 2 equations, which means they're going to give you 2 sentences in that problem to help you do it. This, what I'm underlining in blue, is going to be used for equation 1. This, what I'm underlining in red, tells you something else. That's going to be used to help you set up equation 2. Let's start with the red one. Okay, that one's easier. Maya, what does it say in red?
You sell 4 more large candles than.
All right. So another way to think about it, I'm just going to reword that sentence in a way that I think it makes sense, but I'm going to just say it a different way. Large candles sold is 4 more than small candles sold. It's the same sentence, I just worded it a little differently. Large candles sold is 4 more than the number of small candles sold. How are we representing large candles? Why? is always gets translated to what in math? What is? Like if I said x is 2, equals. We already have that right there. So large candles is 4 more than small. How would you write 4 more than small? 4, yeah.
Plus I.
Plus x. There's one of your equations right there. Large candles is 4 more than small. So if x was 1, y would be 5. If x was 2, y would be 6. However many small ones you sold, add 4 to it, and that's how many large ones you sold. Okay, so that's half the problem. If you got that, I give you half credit. Now, what's in blue? We have to write that one. You spent the small candles are $4 and the large candles are $6. And you make a total of $144. So how many different things are you selling at this craft fair? You're selling 2 things. So you have to take, let's write it like this. Money from the small candles you sell. Take the money from the large candles you sell. So money from small candles and the money from large candles. And how much money did it say we made at the craft fair?
144.
And what would you do with these 2 things? You take how much money from the small candles and the large candles and do what? Add them up. So that's going to be part of our second equation. Something plus something equals 144. What we have to put here is the amount of money you make from the small candles, and what you put there is the amount of money you make from the large candles. Now, let's look at the small. How much did small candles sell for? $4 per candle. So if you bought 2 of them, how much money would that be? 8. How'd you figure that out? Times them together. So the money you make from small candles is 4 times how many you sold. If you sold 10, 4 times 10. If you sell 50, 4 times 50. If you sold 9 of them, 4 times 9. Now, large candles. How much does each large candle sell for? $6. And how many of them did you sell? We sold Y of them. So if you sold 2, 6 times 2. 12, 6 times 12. Y, 6 times Y. And that is your second equation. Now, from here, you would have to graph that. I purposely didn't want you to graph it because the numbers are too big. I just wanted you to set it up. Okay? We're going to practice more with the word problems. Those are the trickiest ones. Okay? But that's it. Those are your answers. Okay, so just a reminder, Thursday, review day with MCAS. Progress reports close on Friday. All right, so nice job today, guys.
Like Super Saiyan.